Morning all, welcome back to day 3 of Nextflow training. So I'll just cover what we went over yesterday and then we'll jump into today. So again, if you're following along on the Zoom, you can jump into the environment, log into the Cloud9 virtual environment as before. The instructions are there at the top of the page. So the main things we looked at yesterday was going over channels and how we can create these channels, how we can use the channel factories, essentially put our data inside these and then use these in downstream processes. And we began by looking at the basic structure of processes then and how these can be used. We remember that they have this structure, we have the process, the name. We can put some directives, which is the first thing we'll look at this morning, and the basic concepts with the input, the output, and the script section. We created this very basic process. This is a FastQC process that we had here, where we defined some parameters, which was some reads. We then created a channel from those parameters we had here, and then this channel became the input of our FastQC process. And remember that was the structure of this channel, the structure of the elements in this channel that had a value, a sample ID, and then the files, which we used to then be able to create that. The other thing we looked at was how we can create these Nextflow variables on the fly. So we create the sample ID on the fly, which we can then use in the script section using this $ notation. And the same thing for the read files themselves. So here we would be able to access, for example, the actual file names by putting them something like this into here. We also at the end looked at outputs and how we can dynamically name these. So we can use inside the output section, for example, the sample ID here, which is be able to be dynamically named. And that means the file would take the name which we specify here. So for example, if we created this one, which was sample ID.txt, this would be what Nextflow would look for at this end of the process. And this file would go into the resulting channel which gets created. What we're going to look at today is first off, starting by looking at this directives section. Then we're going to see a little bit on how we can organize our outputs. This means where we can take the output of our processes. Remember that all of this is happening inside the working directory. And this may not be the most convenient place where we're able to get it. So we can organize these, and we'll see in a moment how to do that. Then we're going to look at operators. And operators are ways for us to manipulate the contents of a channel. So we can change the elements inside a channel and we can combine channels, we can fork them, etc. So in doing that, we'll be able to then obviously change the execution. And then we're going to have a brief section, or this is probably more for reference, on the very basics of Groovy. So this is just here so you understand how we can print the screen, for example, go through the comments. And then at the end, so for the last hour or so, we're going to run through a simple RNA-seq pipeline where we're going to pull all of the syntax that we've learned over the last couple of days, bring all that together inside a pipeline, be able to run that, and then show how we can use, for example, the Git integration of Nextflow, how we can start to run containers, etc. So that's the plan for today. We'll start off though, as I said, with these directives. And directives can be thought of as kind of config for your processes. So that means that there is some specific set of these configuration which we can apply to the processes. There is a whole bunch of these. I can't remember exactly how many, something like 40 or 50. If you go to the documentation in this link here, you can see the list of these directives here. So some of them are very specific to almost like the hardware. So you can have directives that specify which accelerator you want to use. Some of the common ones which make sense are things like CPU, so specifying the CPU for a specific process, the container you use for a process. We've seen before we were using echo, which is being able to print things to screen. We'll see label in a moment. Things on how the task is rerun, so the ability to retry based on some errors, and a whole bunch of these things. So most basic one that we will look at to start with and see how to use is this tag directive. And the tag directive is just simply a way of logging something, or giving a tag to a specific task. And the way that we can apply directives, if we look at the documentation again, we see the example of how to use these. So we remember that the directive goes directly under the process definition. And in this case, it's just tag, and we can put some code in here. So let's go back to our example that we had before. Just check that this is working here. Close this one, and then let's just run hello.nf. And now we want to add a directive to this process that we've defined here. So there was a question yesterday about what this one means here. So this one after the process name here is just the task identifier of that process. If you don't place a tag, it's just sequential. So 1, 2, 3 as the tasks are executed. However, we may want to actually apply a tag here. So if we put a tag in here, so I'm just going to go across 1, 2, 3, 4, let's do a tag. We can now put some code. And what would be quite useful to do in this situation is to put, for example, the sample ID itself. So if I put a sample ID here, now we're going to be dynamically assigning a tag to the process as it runs. So I've saved that one here. And notice that this is just a Nextflow variable, which we're defining in the input. And it can actually, that we've been able to place this tag on here. The same thing would be true if we ran this for all the samples. So now we're going to have 3 tasks. To log as false, I see every single task. So you can see there we have liver, lung, and gut. This may be useful if you have a small pipeline, but if you have a large pipeline of thousands of steps, it can be very difficult. So can you assign multiple tags to one process? I'm not sure. We can try. It would be kind of weird, but you can, let's say like this. If you needed to do multiple, you could definitely split them up like this, and you could do some other sample ID here, or something else. If you put there 2, you can test this stuff. I'm not sure what happens. May not like it. Imagine that we had a directive, which was then also a tag, which was also the reads file. Try that. It may just take the last one here. So it looks like it's just taken the reads file there. But if you felt so inclined, remember that this is just code, so we can put in whatever we want here and launch that. Get this, for example. Okay. So tag directives, fairly basic, useful for seeing what we've got. Other directives that are very useful and that you'll see very often is this publish dir directive. So as I was saying before, remember that each of these tasks that we are launching is in its own working directory. So just a quick recap from yesterday. If we see, for example, this task has this hash in front of it, 1B, 1D, CA. If I do an ls on the work directory on 1B, 1D, etc., you can see that this is where this task has been executed. Now, imagine that in this case, we're capturing an output. In this case, it's sample ID.txt. So for this task, it was liver.txt. This is what we want to imagine. This is the end of our pipeline, and we want to use this for some other analysis outside of this specific Nextflow pipeline that we're using. We wanted to give this to a colleague or something else, so we'll use this downstream. It's not super convenient for us to be able to have to go into this directory, figure out, firstly figure out where it is, and then organize this in a specific way. The work directory is made to be very functional from a Nextflow perspective, but not specifically from a user perspective in terms of having to remember these numbers and how these numbers relate to a specific task execution. So for that, and for taking the outputs out of our pipelines, we can use the publish-dir directive. And you can see how the publish-dir directive works here. I'm going to just link to the documentation here because all of these, the documentation helps you a lot in all these cases. So you can see that the publish-dir directive takes a first argument, which is just a location. And what will happen is that it will output all of the, it will take, in the first case, all of the outputs from the process, and they will be placed inside this publish-dir directive, and inside this publish-dir location, sorry. So let's do this with us. Let's imagine that we have our example that we have before. So we had, we want to take now this liver.txt sample, and imagine that we wanted to place this in some results folder. I'm just going to remove this for consistency. So say publish-dir. Now I want to place this in some location. Let's imagine that we said results /fastqc, and that's the location that I wanted to place this, the output of this task or this process. So I'm going to save this. Now when we launch this, let's just run this again. We see that the process is run 3 times here. And if we now look inside this directory results.fastqc, you can see actually on the left-hand side what was created. So the folder results was created for us, and the fastqc folder was created for us because this is what we define. And then we have this gut.txt. But notice something about this gut.txt. This is probably easier if I see something here. If I go into results in fastqc, notice how by default, this is actually not, hasn't copied the file specifically. It's actually just symlinked it. So it's symlinked it to the task directory where that file was created. And this comes back to the options that we have available to us when we're using publish-dir. So notice that like all of these directives, you typically have a bunch of options associated with each of them. So by default, we are creating a symbolic link. This means it's just creating a link to where the working directory is, so where the file is inside the working directory. But we can change that by changing the mode, that publish-dir is working in. The examples of the mode that we have available to us are symlink, relative symlink, a link, copy, no follow, and move. So something to note on move: if you move the file, then you're obviously going to invalidate the cache. So kind of do that with caution. Let's imagine that we wanted to do a copy though in this case. So now I want to clear this. I'm going to remove the ones that I had before, so we can just remove the results directory. I'm going to now change this. So now we're going to use, instead of just having a single argument in publish-dir, we're going to see from the, in the training example here, that we can use this comma, mode, and then what the mode that we want. Let's do copy. I'm going to put mode copy, save this. So let's firstly launch this. And now when we look at the results here, as before, we can see that this is the actual files now. They've been copied out of the work directory into our publish-dir results folder. So a question before about for the tag sample ID, does this refer to whatever is in the input? So for the tag, what we had before, we had sample ID here. So we had tag sample ID. This is actually just any piece of code. So if the reason I was using sample ID is it's kind of a descriptive it's a good descriptor of what the task is executing. If I was to change this to, for example, X, I could put X in here, and then I would change this to X. It's whatever you prefer. You can even put more complex descriptions in there. It's completely up to you. And then this is a question of a question now relating to published error that says, let's imagine that we're working on large files. How would the process time change depending on the mode that we're using? But I think in terms of the Nextflow execution, you typically will think of it that each of the tasks is running in parallel, or as parallel as you have resources to run in. And the actual execution of the jobs will be, the actual execution of the tasks should be running in a distributed manner, typically for very large data sets. And then it's actually the core Nextflow job, which will be doing the symlink copying itself. Okay, I'll let Paolo answer the ones under there about Unix pipes. Okay. There's ways to handle subdirectories. So you can use publish dir to handle several of your outputs. Imagine that we had a set of outputs which were being created. This example gets a little bit more complicated, but the key point is that I'm trying to here capture a couple of things. Imagine if I wanted to put my FastQ files in one folder, and I wanted to put my counts files in another folder, another directory, a subdirectory of the original one, and then I wanted to put these Outlook files into another subdirectory. So we can use the multiple published dirs inside a process, inside the process directives. And we can also take that using the pattern that we see here. So this is this pattern where we can specify a glob pattern to select which files will be selected from the overall set of output files which are captured by Nextflow in the output definition of our process. Okay. So if we were to run this, we would see that we would get several. We could, I think it would be a somewhat similar example as if we had this here. Imagine that we wanted to now, if we captured all of our files, so imagine our output now is just everything. So this was just going to capture everything and put it into this FastQC channel. We could have, for example, the reads. This is slightly, doesn't make so much sense because we're capturing the input and placing it into the output directly. But we could do something like this, and then we would look for a pattern. So in our case, one of the patterns that we would be looking for would be .fq, because this is the name of our files. So let's remove this to be clear. So imagine that the FastQC was a text file. The pattern that we were looking for our reads was a .fq. I'll just delete this previous file. There it is. And then pretty sure this should be able to capture what we're looking for in terms of being able to split, our task. There must be some. Oh, there must be something. Let's check how that looks exactly again. Okay. Still needs a bracket on that. Sorry, it still needs a. Okay, and now when we look in here, look into our results, we can see that we've got the actual text files, which are there, and then we also have the reads files, one layer deeper inside there. Okay. So operators now. So if we think about their operators, these are ways to manipulate the contents of our channel. So you can imagine that one way to manipulate the files that you have in your channel would be to create a process, would be to take a process and do some, run some bash script or some Python script and actually operate on the files that you have there. But operators are really built-in functions that we can use to manipulate channels, that we can really manipulate them from the core Nextflow job, which is running. So operators are typically not farmed out to your specific tasks. So they're not run in a kind of distributed manner. They run on the core Nextflow job. And they're typically small modifications where we're just pulling the data structures together, forking them apart, or running on them. This is a quick visualization of what's happening. Imagine that we have a channel called nums, which contains 1, 2, 3, and 4. So 1, 2, 3, 4. These are the 4 elements that are inside our channel. What we do when we run an operator, in this case, we're going to run the map operator. And we are creating a new channel, which we're assigning to the name square. So square is a new channel, which takes the nums channel and has an operation on it. And with the map operator, we have a way of defining what it does. In this case, it's IT. Remember yesterday, item is a special keyword, which just means the actual item itself, the element. Take the item, multiply it by itself. So the item times the item is the result in our square. So let's have a look at that just to show you how this works. We'll go into more of the exactly how these different operators work in a moment, but this is just a quick visualization of how this works. So let's just save this here. Nextflow run operator. Okay, and this will launch through, and we'll see that we got 1, 2, 3, and 4 became 1, 4, 9, and 16. What's happening when we're performing this operation? So initially we started with a Q channel, the 4 elements inside that were transformed, and they were coming to a new channel itself. The nice thing about this is that we can also chain operators together. And what this means is it allows us to perform multiple operations at a time. So consider the example that we have here. In this case, we can see that we're creating a channel. Oh, we're creating a channel on the fly. Sorry. And then we are taking that resulting channel, we're performing an operation on it where we're doing the map. And then we're taking that resulting channel and we're performing another operation on it, in this case, the view. So this results in the exact same thing. It's just another way of writing this. Kind of two approaches that you'll see here was that you could either, for example, assign a channel name, my channel here, and then you could use, for example, my channel down. This is just essentially a way of providing a channel name. This is the same thing here. And now we have a name associated with this, or we can just keep going and we can just chain these together as we need. So obviously for a process, when we want to use a process, we should give it a name. And there's a couple of ways of doing that. So the first way you saw was assignment. And you'll see that there's another way of assigning it using an operator, typically at the end of a chained set of processes. So the different operators that we have, so filtering, transforming, splitting, combining, forking, and maths operators. You will find all of these in the Nextflow documentation. So again, I'm going to go back to the Nextflow documentation, look at operators. The total list, now I think this is over 50 or so of these, and you can see examples of how you use all of these. Becoming familiar with some of the most common ones is particularly useful. So things like how to use map, the basic operations is very useful. Combining is very important. Split, so split CSV is very useful. It allows you to take a CSV file and split it so that the elements are essentially the rows of your channel, or the rows of your CSV. Combining becomes very useful when we need to do, for example, a join or combine on a key. We have ways of forking these, so be able to split a single channel into multiple channels and then some basic operators and some other ones. So for example, view, which we've seen before. But let's start from the beginning. So view is a very basic operator. It's the one that we've seen a lot here. It allows us to simply view the contents of our channel, and every element is just emitted to the console with a new line character after each of them. So we see before, we have 3 elements in our channel, which we're creating. And then when we run a view on this, we can see that we just get the output channel. So the output of each element is printed to the screen. Very useful for debugging. You can think of it as the equivalent of your print statement when you're writing more traditional like code. We have ways of having operators, of putting closures, on the end of our operators. And this allows us to take our take what the default behavior of the operator is and modify it in this particular way. So I'm going to go to view here and have a look at what the options are that we have. And these typically come with an example of how you can use them. So in the basic example, we have .view, which is just going to be printing the contents of it as we've seen before. We can see that we can specify an option on here. So new line equals false. This would be an option which we can pass into the view command. And what we also see is this additional optional closure parameter, which is a way of controlling what is being printed. So I'm going to take this example because it shows it a little bit more sophisticated way of using view. So in the first case here, I'm going to cut this for now just to show you what we're doing. We're starting with a channel containing 3 elements, 1, 2, 3. We're then going to do something which you see very often, which is to do a map, which is to manipulate that channel, to take every element of that channel, and for every element, create a tuple which contains the original element and the element times itself. Let's take a look at that. When I run this, now we'll see that we still have 3 elements, but each element is now a tuple containing the element and the element multiplied by itself. This is actually a closure in itself. It's a way of manipulating or of changing the behavior of the map operator. You can see that we can also have a closure operation on the view. So in this case, because our channel, which is emitted from the map here, contains a tuple, so 2 elements, the first, the item times itself, we can say that, we say the item or the number and the square of that number, we can use this number, comma, number, and then we can say print that, and actually what you want to print is this now becomes a variable, this one which we've defined here, this becomes a variable, this will become here, and then we can use that to manipulate and to actually print that contents. So if we run through this, here you go. So square of the variable number is the square of that number. And you can see that that will be viewed for every element that we have inside of that channel. Fantastic. Okay. Map. So map is can be thought of as a special kind of operator in the sense that it enables us to apply any kind of function. It enables us to apply a function of our choosing to each of the elements in there. So this example here, we're going to take hello and hello world. We're creating a channel, 2 elements. We're going to take the item, and the item is going to be mapped. So there's going to be a map operation. So for each element in that channel, we're going to take the item and we're going to reverse it and we're going to view it. So here and run through there, and you can see that that occurs in this way. So we're just reversing that. Like we said before, we could also create and modify the structure of this. So what I want to show you here is if we look at this example, and then I want to quickly jump in and imagine how this would look for a process, because this is one of the key parts to get right in Nextflow. What we're doing here is we're going to create, in the first case, we're just going to create 2 elements, hello and world, 2 strings. We're going to do the map operation. And now we're going to create the output channel is going to be a tuple of word and word size. This is very similar to the example we just saw before, where we created an item times itself. But let's do word, hello, 5, 1, 5. Again, if I change this, we can have whatever we want. But the key thing to note is the structure of this. This is now a tuple. This is a tuple of 2 elements. So if I was to have a process down here, and if I was to say, for example, have a process called greeting, and I wanted to now use this, we would have to make sure that our inputs match this. Because this is a tuple, I would have to say tuple, and then let's just say something like the value. We can assign this to whatever we want. This could be word, and this could be value, word size. Let's say something like this. Now we have to set this channel's name. For now, let's just call this our words channel. So notice that we use the map in this case here. We use the map to modify the structure of the elements in the channel to fit our process. So we've now changed the structure of that channel so that it fits our process here. I'm going to have to remove this view. I'm going to use this words channel as my input. And then I can simply have a script section here where I could say echo, let's just say word is $word, and size is dollar size. This is a key point, making sure that we're able to take our process, take our channels, the elements in the channels, make sure that they match. In this case, we took something which was a word, a single element, does not fit into our process here, but we converted it into a tuple, which now matches the cardinality of that process. So let's just confirm we've got this going, and we can use this example to go forward for some of the other examples here. Let me just check there's nothing crazy here, and let's just do another. Since we just looked at this before, let's use this directive now. So we can say echo is true. So now you can see that this is the equivalent of what we had before with our directives. This should now print the contents. Shouldn't it be word size in the script? Probably yes. That's exactly right. Thanks for watching. Keep an eye on these things. Okay. The script needs a semicolon there. Oh, I think I saved that. Cancel that. Let's try this. So we've got the variables there. They're matching up with the channels, and then we get this process being created. Word is hello, size is 5. Word is world, size is 5. Perfect. Awesome. Thanks for pointing that out. Okay. We can also do the same thing with files themselves. So we can imagine our pattern that we had before. Say that we had here this from path. Now we're going to use files themselves. And this is quite useful for example, if we had a example here, let me just say, let's paste this in here. Now we're going to take from path. So now our channel is going to contain files themselves, not necessarily just values now. So we're going to say my files channel, in this case, is from path here. I'm going to perform a map on that. So we're going to take each file. We're going to map that from the file itself. This is a keyword here. We can just say the file. Now it becomes a value. We can then create a tuple which contains the file.name. So this is a special name of the file. This is a kind of method that we can call on this file, and then the file itself. And then if we wanted to view this, we could do that, but let's actually use this downstream. It's more interesting to put it inside a process. So now my process though has to match it. What do I have? I've got a file.name, which is actually a value. Let's just call this fname. I have a file itself. I have to change the type here. If I want to use this file which is actually a file because it's a file object from path, I should change this to file. And here let's call this read, or reads from our files channel. Okay, now let's do something similar. Let's say echo, we are doing alignments of these, in this case, let's say, imagine that the F name was a sample, so the sample F name with the reads. Okay, just point out to me if there's anything obvious missing here, and we'll launch this. Now remember that we have 6 of these files which match this. So in theory, we should get 6 executions here. So 1, 2, 3, 4, 5, 6. And the alignment of the sample, I'm going to score 1 exactly. So this is actually just taking the file name. But there's a difference here. This here, this is now a file object. And the key difference here is that if I was to go into each of these work directories, so for example, 6B, so ls work 6B, etc. Sorry. Notice that if I had this as value here, this would not have been imported. So the actual file itself would not have been taken in. Because I use file, now the file is in that working directory. It's staged and I can use it. Another thing to note is, what is that? And I'm not sure if we covered this yesterday, but if we look at what by default is what is pulled into the working directory by Nextflow, this is actually a symlink to our original data. The full path of our original data is pulled into this thing. So something to note, the difference between using this file and why that is important that we have this as a file object when we pull it into the process. Okay, so jumping back into the operators. So we have the channels. In this case, we have an into operator. This is not really required in the upcoming version of Nextflow, but you'll still see this in some existing scripts. Imagine that we wanted to use this channel 2 times. So in 2 different processes, or perform some operations on it. Here we would say, we've got 3 elements in here. We're going to essentially clone this channel, you can think of it. Can do a complete copy of it. And note that there's this semicolon here. Fairly basic what happens there. This gets a bit more interesting. If we want to now not split our channel into 2 channels, but if we want to combine multiple channels into a single channel. So how does this look like? Imagine that we have, for example, here, imagine that I had channels which are generated from different processes, and they were coming from several different processes that I was running, and I need to bring them all together. And we'll see this in an example later today, but this mix operator is essentially just going to take each of the outputs of those channels and create it into a single channel, which is a kind of a full mix, or kind of like it could be like considered like a stack of all of the single elements. So now we started with 3 channels. One channel had 3 elements, one channel had 2, one had 1, and we've ended up with a single channel here. This is a single channel which contains 1, 2, 3, 4, 5, 6 elements in it. Okay. We also saw yesterday the use of the flatten operator. And the flatten operator allows us to take tuples or lists inside of our channels and make them perfectly flat. So we could imagine we created a channel from a couple of lists. Let's start this slowly. So we'll start the first case. I'm going to create a channel here. I'm going to remove flatten to start with. Imagine that I had this 2 channel. Let's have a look what it looks like. If we run this, we've created this channel and it contains 2 elements. One of them is 1, 2, and 3. One of them is 4, 5, and 6. Imagine that we also could have, I'm not sure if I think that this might work. Imagine that we had like a more complex channel. So something like this. That's matched up there. Okay. Now you can see that, imagine we wanted to take each of these now. We've got one is a tuple that inside it contains its own tuple. The other is a tuple of 3 elements. So this is a tuple of 2 elements. One is a tuple itself. Now if we wanted to take all of those and flatten them out, when we run this, we get each of the individual elements inside of that. So the whole thing becomes flat, and we can run them in that way. So it's very useful for taking a collection and essentially being able to run a process over each of the elements which are emitted from that. The opposite of that is collect. And what we're doing with collect is we're taking a collection and we're actually converting it into a tuple. So imagine that I have this, and let's do the opposite. So I've got this here. In this first case, I have now I've got a channel which contains 4 elements, 1, 2, 3, 4. So we have 4 elements. This would be the equivalent of 4 processes or 4 tasks of a process being executed. If I was to add on collect here, now when I run this, I have a single element. So we'll also see, keep this in mind, we'll also see an example of this later. This can be a situation where you want to take, say, all of your inputs from a channel. Imagine that you run something against every sample, and then you've got like 1,000 samples, and then you need to pull all of those 1,000 samples together into a single process to run, say, some comparison between all of the samples, for example. Okay. Now we get to some slightly more sophisticated ways of grouping our channel elements. So the example that we have here would be, consider that you had a key. This could be a sample ID. And imagine that you had multiple samples for multiple actual files for each sample. So with this question actually came up yesterday. Imagine that I have, for example, for one I have, which is a sample ID, I have several files. So for one I have A, B, and C. And I want to now pull all of my samples with the same identifier. In this case, it's a number together. To do that, we can use what's called group tuple. And group tuple will search for all of the matching elements based on the first element inside that tuple. So it's going to look for all of the ones and group them together. So this is going to be A, B, C. It's going to look for all of the 2s. So this is going to be 2C, and it's going to be 2A, and then it's going to look for all of the 3s. So this is going to be 3B and 3D. There's also multiple ways of running this. So this is, as we saw before, this is just the example where we have a default behavior, which is based on the grouping from the first element of that. So we see that. However, if we were to go here and look at the combining here, sorry, if we want to do it, it's a group tuple. Yeah, group tuple. Okay, so this is the example that we saw before. So group based on that. We can also use the various options that are coming with group tuple. So we can group by, which is to choose which elements that we're grouping on. So consider this. If I was to now change that, I don't want to group now on the first element, the number. Imagine that I wanted to group on the letter. I could say group by 1. So this is a 0 indexed situation. So by default, this is what's happening. This is a default behavior, group on 0. So group on the first element. We get this. If I was to change that and say group by 1, that here, I'm able to group here. And now it's the matching part is on the second part. Yeah. Okay. There's a question that's coming. When we use flatten, how deep does it flatten the array? Is there a limit? I don't think there is a limit, not that I know of. So you can imagine as it goes through, I think that we see there that in the example I showed you before, it went so deep. Have a look if there's any sort of limits on there. I don't see anything. So I would guess that it just keeps going. Okay. There's an exercise there if you want to do. This is actually something similar to what ends up happening with from file pairs. You remember that we had created this, we had this channel factory yesterday for creating pairs of files. Well, in this exercise, you can actually recreate that channel factory, but beginning with from path. And this is a way of showing how you can manipulate the contents of your channel to create something that you wish to have. So this is just something useful for having. Other parts, so we have the join operator. So the join operator is then able to now take two different channels and then join them based on a key. So this is, this also came out yesterday. I think we had a question around how we could take two different channels, combine them based on some common element. But again, by default, it's the first element here. So we can see that we're going to take the matching ones here. So X and 1, and then X with 4 in the second channel. We have Y with 2.
And we can't see your screen anymore.
Oh, sorry. Not sure what happened there. Let me check this. Apologies for that. Not sure why that happened. Awesome, thanks for letting me know. Okay, so I'll just recap there on the join. So join is where we're going to bring these two different channels together. You can see that we have a channel called left, a channel called right, and we're going to join them based by default on the first element of that. So in the first case, this is going to be joining on here. So X with 1, X with 4. You can see that this is created here. We can see Y with 2 and Y with 5. This is created here. And we have Z with 3 and Z with 6, which is created here. Notice that here there's a remainder though. So we have one which doesn't match these. And again, this is one of the situations where you can control this behavior using the options. So if I was to look in here and imagine that I wanted that behavior from my pipeline, I wanted to, for example, look at the combining operator, I would look at join, and I would see how this can be used. So by default, we have the first element that we have, sorry, the first channel that we have, we are joining it with the second, and the second argument here is remainder true. So if I was to put into my example, I haven't copied that through, but I'll show you in practice through here. Okay, so we define two channels. First behavior here, we are leaving out this remainder. Again, this is so its P is not there. And in the second case, now if I was to do remainder, it's true. So I put this as an option inside my join function. So my join operator. Run this. And now we will get the P7 is actually presented there. But it says null because we do not have a second value for the right one there. Okay. And then the final one that we'll look at before we'll take a break, and we'll actually quickly go through the Groovy, and then we'll take a break. So we have the branch. This is a kind of a new operator, and it does something slightly different from the others in that it's able to branch a channel that you have, a source channel, but it is able to output multiple channels from that. So we can see that what we're doing here is we're taking a channel which contains 5 elements, 1, 2, 3, 40, and 50. We are then doing a branch, which is an expression now which gets evaluated. So branch is saying, okay, create now what's called a multi-channel object. So now we have a multi-channel object which contains small for the items below 10, so these ones, and then large for the items above 10. So this will be these ones. This is still a single channel here. So result is a single channel. However, we can access the parts of the channel, the multiple aspects of the channel using this result dot the name of that. So this can be useful for splitting up parts of your splitting up parts of your channel based on some evaluation. Okay, I'll just spend a couple of minutes. I don't want to go through this in too much detail. It's more, as I say, more for reference. We have some basic information on how you can use Groovy. So it starts with very basic things. You can use print line for just printing this. We've seen this a couple of times. Comments in both Nextflow scripts and in Nextflow config, you can use the C family of commenting. So we use this two forward slashes for a single line comment. We can have multi-line comments. We've seen this a lot. We assign variables in a basic way. You can see that here we can actually access underlying Java libraries. So we could use, for example, a date. This is a type here. And we can have complex, we can have numbers, we can have Booleans, strings, integers, etc. You can define a local variable, and this is useful for when you're defining a variable inside a function or inside a closure, which we'll get to in a moment, if you don't want that variable to be global for your whole script. Lists that we have, accessing the values of a list. So this assert word here is just, it's basically saying confirm that that is the case, otherwise throw an error. So this is just showing you that you could take this list, you could access the first element of it, -0, and it equals 10 that we have here. Another way of accessing the equivalent way of accessing the elements inside of a list is to use this get and then the index of that. We can get some methods on a list. For example, we can see the size, confirm that the size of this list is 4. And if we wanted to, we could also access, for example, the range of it or capturing this value from the other end. So coming from this side, -1, we would get 2, etc. You can have a look at, there's all information here on how we can also access the Java util list interface, as well as the Groovy API, and there's links there for you if you want to access that. We have maps, which are very much similar to dictionaries. So here you have a key and then the value. So this is just a typical key value system. Again, you can access the values by providing the key in a similar way that you see there. Okay. Something to keep note of, and you saw that I made this mistake yesterday, was with this string interpolation. You can see that we have to use this a lot in Nextflow scripts. And for terms of being able to pull out the Nextflow variables or using the Nextflow variables, notice that we have this columns here, focuses here, and then we have the actual $sign for the variable name. And the key point is inside these curly brackets, we're able to put code itself. So then we can actually have expressions inside here. So this can be useful for example, when you're defining your outputs, if you want to define them dynamically, we use this key. Some differences in terms of the escaping the delimiters. So escaping these characters, we can escape the T here. This would typically come out in this situation here, where it's going to think that this is a tab. But in this case here, we can use these characters here, so slashy strings, to avoid this being the case. We have multi-line strings, which are essentially what's happening inside of our script section in the Nextflow block. So you have a block of multi-line string. Again, you can do a similar thing with the slashy string here. We can have expressions. Don't want to go into this too much. It's sort of here if you want to read this and take that there. For statements, very simple, sort of basic stuff. We have the definition of functions. Closures is something that we see a lot of, and closures are actually used quite a bit by the Nextflow operators themselves. So you can think of these as anonymous functions. So they're a way of us creating a function, but without having to provide a name to it. So if we see an example here, we can take this sort of definition here where we can create X here, and then we can call the function, for example, with a collect on here, and this is the square against that. So imagine that I had a closure here. This is square equals the number times the number. We saw this very much similar to our map operation. Here we define a value. This is number, it could be item. So item goes to number times number, or item equals item times item. If we assign a name here, then we can use it later on in the closure. Okay. If you want to look into more information of this, have a look into the Groovy documentation here. There's some really nice books around this for the complete syntax here. So there's a book, Groovy in Action, which we recommend reading if you want to go into more detail. Here you can see all information on exactly how these works, much better examples than we can provide in this short course. Yeah, so I'd recommend that if you're interested. I would say overall, you don't need to know much Groovy to write Nextflow pipelines. It certainly helps to have a basic understanding of how to use it, or at least be able to look up examples of how to use it. But for the majority of your Nextflow pipelines, some sort of basic Groovy is all you really need. Okay, so we've just gone a little bit over time for that. So maybe we'll come back in 7 or 8 minutes or so. So let's say 38. So give it 10 minutes or so, and then we'll come back and we'll jump back into our RNA-seq pipeline. Okay, welcome back to the second part of day 3. And now we're going to try and pull together everything that we've seen over the last sort of 2.5 sessions, where we're going to build a simple RNA-seq pipeline that's going to take all of the parts that we had. So we're going to define some inputs, some reads. We're going to create some channels from those. We're going to define what some processes are. And then we're going to pull it together and create a final process, which is going to use some operators to pull our different output channels together and create a multi-QC report. So this is a very basic RNA-seq pipeline that uses Salmon. It's got 4 steps associated with it. So indexing, doing some quality control using FastQC, doing some quantification using Salmon as well, and then creating a multi-QC report from the FastQC and the Salmon quant processes. So all of these scripts are available to you inside the work environment that we have. So we're going to start by building this up slowly, and we're going to look at starting with script number 1. So let's say script number 1 you have here. The only thing that this script has is the simple definitions. So our parameters. So we have our parameters for reads files. So we're going to define the exact same reads we've been using all along. We have a transcriptome, again in the same location, and we have a multi-QC, which is a kind of config parameter that we have here. The most basic case, if we were to run this, we can see that now we're using print line, and that print line is simply printing the parameter itself. So if I was to do Nextflow run script 1, launch this, and you can see that we're getting this printed here. So we're just printing the parameter. So imagine that we want to recap this. First things that we want to consider is that we can change any of these parameters from the command line using this dash dash and then the name of the parameter. So consider that we were to run the pipeline with a different set of reads. We could do this by saying Nextflow run, saying same script, and using this dash dash reads would now modify the parameter. So the command line in this case has precedence over the parameter definition inside the script. And this is a nice way of having some, say, small default data that you run, associating your script, and then you have a way to run this on actual data itself. Okay. So the first exercise that we're going to do is we're going to modify script number 1. So the same script that we have, and we want to add a 4th parameter here. You can see that we have 3 parameters: reads, transcriptome, and multi-QC. We're going to add a 4th parameter called outdir, and this is where we're going to store the output of our pipeline. We're going to put the results in here. The next thing we're going to do is we're going to modify the script, and we want to print all of the parameter pipeline, the pipeline parameters, into a single command. So both to the screen and then also into a log, and we'll see how we can do that. So the first case, I'm just going to add a fourth parameter here. And I'm going to do this called outdoor. In my case, let's just start and do something basic. Let's just call this results. Now what this means is that when we use this params.outdoor later in the pipeline, say for example as a publisher would be a good place to use this, we would then be able to modify where the output of the pipeline goes, both from the command line but also in the config, and while at the same time having a default location there. Okay. We'll see when we come to use this later on. The next part that we wanted to do was add a multi-line string statement and print that to the log. So there's an example here of how to do this. And we're just going to print this in. This is going to create like a kind of nicer output to our command. So we can see that we're going to create this thing. It's going to be the name of the pipeline. And then everything as before. We're going to get the transcriptome, the reads, and the outdoor. Provides the user with a little bit more information about what's happening in the pipeline and our parameters that we've now also stored in a log. So let's just run through this, and you can see there. Fantastic. Now you can see, remember that we've got the full path here. You can see that we've used this $sign to donate this Nextflow parameter. So this Nextflow variable here, which is taken from above. And you can see that we also did the strip indent, which is just removing the white space that's associated here with this. This is just allows us to format it slightly better. So log.info, one thing we haven't mentioned is that Nextflow has a log for each time that you run. So if we were to do a cat on the Nextflow, it's under .nextflow.log, you will see that this is actually what's run here. So this is the log of Nextflow. It's useful for really debugging, or if you end up with, if you have problems specifically. So if I was to save this here, just format this slightly nicer. Every time I run this, every time I run the script, a new Nextflow log is created. And if we were to put cat on that log, oops, sorry, you can see that this information here has been placed inside the log that we have. You can see that that's there. You also get some information on each of the tasks, etc., useful for debugging. So that was on the .nextflow.log. Okay, so in our first script here, defined some parameters, printed that to the log. We understand what's going on, what's the input to our pipeline. It's essentially done. Now let's go into something slightly more interesting. So now we're going to look at script number 2. And in script number 2, you can see here that everything is the same as above. Sorry, we've got the pipeline input parameters. So the reads, the transcriptome, the fastqc. We've created this outdoor for a results directory. Again, we have the parameter here. Now we're going to look at our first process. And now we're actually going to start into the first kind of bioinformatics task that we've done this whole time. This process is going to create a binary index from our transcriptome file. So our transcriptome file is simply a FASTA file which contains the transcriptome of this is actually a chicken sample, I think. And here we're going to define the input of that, which will now in this case be a path or a file, the transcriptome, from the params.transcriptome. And then they're going to have an output, which is going to be the index. Now let's take a look at the actual script section though. This is the kind of most important part to understand. We have Salmon, which is a tool. This is a command line tool that we have. Index, which is an option on Salmon. So we're going to do Salmon index. Now we've got some other options that we have here. We can see that we've got this threads, which is a Salmon option for specifying how many threads you want to use or how many CPUs you want to use when you run this task. I'm going to come back to this in a moment. The key parts for us in terms of the input is this transcriptome. This is a Nextflow variable taken from here. So path transcriptome from here. And then we're going to create an output folder called index. The way Salmon index runs, you use this flag -i and it creates the index itself. That means that when this task is complete, Nextflow will look for a directory called index and it will place it into a channel called index channel. So a new channel is going to be created which is going to contain the index. And this name is here. So you can see that this is actually a string it's going to look for here. This is a Nextflow variable here. Okay. Let's run this. So we have this available to us as script number 2. So I'm going to close script number 1, open up script number 2, and launch this. So run script 2. Okay. And what you'll notice, the first thing that we do when we try and run this is that we get an error. And if we read through the error, exactly what that is, we can see that it has this exit status of 127, and the command is saying it's trying to run this command, but salmon is not found. So why is this happening? This is because we don't have salmon installed on our machine. So let's consider if I was to do salmon here, it's not found on this machine. So typically, what you would do would be, okay, now I'm going to go install salmon on this machine, etc. But that's not what we're going to do here. This is not kind of the. Now we're going to see a first introduction into how we can use containers in Nextflow. So as part of the setup process that we have, we've actually got a container which contains the tools required for running this pipeline. So salmon and FastQC and multi-QC. And we're going to spend tomorrow morning looking at how we can create those containers. But for now, we're just going to look at just the Nextflow aspect of it and how we can use that. To run a container with Nextflow, in this case, we're going to use Docker. We simply just say with Docker. Now, when we run this pipeline, we're going to be launching that task inside a Docker container. Salmon is installed in that container, and we can use it. This is a very simple way that we can apply the use of containers into a Nextflow pipeline. I think the immediate question that comes up is, which container did you use? And this is the first time we'll see a little bit of Nextflow config. We don't want to go into too much detail on this because we'll see a lot more tomorrow and the next day. But just to note that the container here is defined in this nextflow.config file, and this is the container that we're using. So this is a container namespace in the container. We'll see much more on this tomorrow, but just take note that if you want to know, the nextflow.config is where that container is defined. For us, we just want to say Nextflow run with Docker, and that will use that container using the Docker runtime. Okay, so that got over that process issue with that there. The other thing to see here is this task.cpus. Now, task.cpus allows us to access the config associated with this process inside the command line. And this is great because it allows us to write our pipelines in a much more portable way that this will run independent of how many CPUs I have available to me. So by default, if I was to look at this command here and was to say, okay, what is task.cpus in this case? Well, we're just running locally. So I'm going to I think it's just going to use one CPU by default. That's just what's given to each process, or what's given to each task by default. I can see exactly what this is by looking inside the work directory. So I'm going to cat work E5 for E, and I'm going to look at a command.sh. So inside the work directory, several things are created. One of them is .command.sh. This is the command which is actually run. This is this with the Nextflow variables placed inside of it. So I'll just bring that to the top of the screen. So you can see that what the command which has actually been launched, salmon index threads 1, transcriptome faster, and then the index. So you can see that this got placed inside here. A quick recap, we'll see more of this later on, but I could, for example, use the directive CPUs, and I could change this to 2. I could change this in the config as well. But when I do this now, and I launch the pipeline, the number of CPUs that will be used by the task, if I was to do the same thing again, oh, sorry, I've lost I've lost the hash of that one. If I was to launch this again, and I was to say now on the command.sh, so I'm going to do cat work 20 f7.command.sh, you can see that now I have 2 threads that were being used. So I don't need to change the command line even if I change my config. This is a good example of by separating out the config versus the workflow logic or the workflow scripts itself. By keeping these things separate, we're able to create a pipeline which is more efficient and portable, depending on the environment. It's a question of, can I use multiple containers in a single process? Yes, you should. Well, you can use single. You can only use a single container for a single task, but you can use multiple containers for multiple. So within a process, so within each task execution, it has to be a single container, but you can specify which container to use for that process in a more dynamic way, and we'll see that later on. We'll also see ways that we can run. Most typically, you will have multiple containers. So for each process, we'll have its own container. We'll have a unique container, and that's kind of the way that things are going. But each task execution, so each one of these single launches here. So now we just have a single task, which is just so index is run once. This has to be one container execution, and the reason for that is it's actually just, in this case, it's a Docker run command with a single container. Okay. We see that we can also change the config here. So we're using with Docker, which was specifying to use Docker. Now, what you may wish to do is, if you don't want to put with Docker every time, or you have any kind of options that are available to you on the command line, you can also use the Nextflow config to change these options. So what we want to do in our case, because we're going to be using Docker every time with this pipeline that we're writing now, at least in this environment, we can use docker.enabled equals true inside our config. So I'm just going to quickly open up my Nextflow config, and I'm going to place docker.enabled equals true at the beginning there. Now, every time I run, I no longer need this here. So we can launch this quickly. And now I no longer need to specify Docker, and this runs. Another thing that we may want to do is to look at what's actually inside this index channel. Okay. So consider that we're now creating this index channel, which is the output of the index process. If I was to do an index channel here and I was to do .view on this, what's actually happening? I'm just going to remove my work directory to make this clearer. Again, run script 2, and I'm going to print the contents or view the contents of that channel. Okay, what's been created? This is now a channel, the index channel, which we can see here. It contains a single element, and that single element is this directory here. Notice that this is in the 42, 88, etc. This is coming from here. So this is the work directory. If I was to do a tree on that location, tree just on my work directory, we'll see everything that's going on. So I removed everything from before. I removed the previous stuff. So we just have this single task inside our work directory. It has this number here. And the reason for splitting up this hash with 2 digits and then a whole series of longer numbers, if this was just a single directory here, some file systems have issues with the number of directories that you can have in a single location. So by splitting this up, by having this 2 digits, and then the rest of the hash inside a subfolder, a subdirectory of that, it allows us to have many more directories without putting too much strain on the file system and slowing things down. But for our purposes, we have a single work directory, this one here. It contains the index, which is the output of the salmon index process. This is just a series of folded files which is created by salmon index, which will be used for later downstream. And we also have the input here, the transcriptome faster, which is a symlink to our original data defined by our parameter here. So this here is the same here. So it hasn't actually copied it, it's just created a symlink on there. So this is the way that Nextflow is working each of these tasks. Lives in its own working directory. The input data is symlinked in. The output data is created inside the task directory. And then the channel contains that location, in this case, this file object, which will be used in the next downstream process that we have. Okay, other things that we can see there. We can see how we define these processes, how we have the inputs and outputs. We've seen this several times now. How we can access the number of CPUs available. So kind of using our config inside of our code and printing the contents of our channels. Okay. Now let's think about our reads. So far we've defined the inputs of our pipeline. We've created this index process and we've run the index, but we haven't done anything with our reads at all. We're going to look at script number 3 and have a look quickly at how we can define this. So script number 3 is the same as the above. Now we're just going to look though at how we can create this read pairs channel. So the channel which is going to contain our reads. We've seen this several times from file pairs. This is going to create create this channel with the following structure. We could do read, so we could do read pairs channel, and we could view the contents of this. And notice here that we have just the gut sample, which is specified here. So when I run this once, let's run script number 3 now. Launch this, and you can see that we just have the gut sample. So the structure of this element inside the channel is a sample ID, and then the 2 files themselves. However, if I wanted to change this, and if I wanted to say, okay, I want to now specify not just the gut sample, which is our default in our reads here, but I wanted to do all of them, I could change this from the command line. So I could say, Nextflow run script 3. Now I'll use all of the reads that we have there, all of the matching that match that glob pattern, and I will get now a channel which contains 3 elements: the sample ID and then the file for each of those. And it's the structure of this tuple with the value and the files that we're going to use downstream. Another thing to note here is, you can see that here I've done an assignment. So I've created a variable for the channel name, read pairs channel, and then from creation of the channel. There's an alternative here though. There's actually an operator which I can use, which I no longer need to define this here, and I can use it downstream. So there's a specific operator for giving something a name, and that is set. So if I use set here, I can then define the channel name at the end. So set is very useful if I have a bunch of operators here. So if I'm chaining several operators together, and then on the last one, I want to give it a name. And the name of that final operator, the final channel can be used here, which can then be used downstream in a further operation or in a process, which is how we're going to use it in a moment. So those 2 things are the equivalent. So I could just do view here. So this here is the equivalent of what we have before. You can see this. Okay. Remember, we also have some options that we can associate with our channel factories. The one that we have here is check if it exists. We saw this previously, but I'll just quickly throw this in here to recap. So when we're creating this channel, we can put check if exists as true here. When we run this, this is a kind of a safety check on what we're running, sanity check. Let's check here. Imagine that I run like this, it should run fine. Imagine that I made a mistake and I thought that these were fast queues, we would aim fast queue, for example. I'll get an error here that nothing matches. Okay. Quantification. Let's go back now. Could you comment on using set versus into for a channel? Yeah, so into, which we'll see in a moment, is used for creating multiple. So if I do into, I could do read pairs channel 1 and read pairs channel 2, for example, here. We'll see this coming up because that's actually exactly what we do in a second. Let's open up script number 4 now. Close some of these. Script number 4. So now we're going to step up to the quantification. And we have everything we had from script number 2 and 3 combined. So we have, again, the inputs, everything stays the same. We have the index process, exactly the same as we had before. And now we're introducing the quantification process after we've created this, this channel, this read pairs channel. So we have our read pairs channel, which remember contains a tuple of a sample ID or a pair ID and the reads themselves. This is coming from here. And the other input of our quantification channel is this index from the index channel. So now we're combining the output of the index process, which is the index channel, with the new read pairs channel, which we've just created from this channel factory here. The structure of the actual command is relatively similar to what we had before. So again, we're using salmon, in this case quantification. We can as well access the number of threads that are available to us as defined by some kind of config. This libtype u is something specific for a salmon setting. This could be a parameter if you wish to parameterize the pipeline, parameterize the script section. We are going to use the index here, which is an input. So this index variable is coming directly from here. And we can have to specify the read. So salmon expects that you define 1 and then the first read, and then 2 and then the second read. Notice how we can put an expression in here that because reads here is itself a tuple, we can access the first element in that tuple using 0 and the second element in that tuple using 1. And finally, we can create an output, which is with the results of our quantification, where we're going to define that output using the pair ID or the sample ID, and that is taken from here. The output which we're going to capture is a pair ID. Again, this is a directory which is going to go inside the quantification channel. Okay, so a few things going on there. The other thing to note, let's run this once first. So I'm just going to run this. I'm just going to run this with just a single sample. So now we're just running just with gut. Maybe something you'd do for just testing. Run script for. Great. Notice how index ran once, quantification ran once because we just have a gut sample. Now let's change things up a bit. Let's do what we had before. So I'm going to say run the exact same script, but I'm going to add some reads in now. I'm going to add all of the reads that we have before. Okay. And as well as that, I want to resume the pipeline. So now I want to add some reads in, but I don't want to redo the steps which have already been done. So I can use this resume flag and then specify the full set of reads. And notice the behavior that we see here. In this case, you'll see that index was the task. There's only one of them. We only need to create one index, but it was cached. So one of the tasks was cached. With the quantification, in the same thing, we need to create 3, but one of them was already cached. The gut sample had already been run. We didn't need to rerun this from the beginning. So we were able to change the parameters of our pipeline. And because of the dependency which is created from the channels, the linking of these processes via the channels, Nextflow knows exactly which tasks don't need to be run and which ones need to be run based on that. So the other thing to note there related to that is that the index runs once because we have a single transcriptome here. This is a single element inside this channel. And because it's a single element, we know that path when using a single element creates a value channel. So this index channel is actually a value channel. This means that we can use it multiple times in here. So because this is a value channel, we can run the gut sample against it, we can run the liver sample against it, etc. So we don't need to create this channel beforehand with multiple elements like you may do, specifically because it's a value channel. Okay, what else do we need to note there? Let's now add a couple of directives into that. Okay, first one question will say, okay, how can Nextflow detect if a change to an input file in place? Say, for example, I replace transcriptome with a different file, but keep it the same name. So Nextflow has quite a sophisticated checkpointing mechanism here. There's a couple of blog posts you can read exactly on how this works. We also will do a small section on the last day on this, but it is looking for when the file was last modified. It's going to be able to detect if you, for example, changed even one, it looks at the size of the file. All of these things go into the input calculation, which is used to generate that hash. So if you, for example, changed it with a certain name, it would know to redo that. I mean, let's prove that there. So imagine that I was to go inside this transcriptome. So I'm just going to quickly change the reads here. So I'm going to go data gggal transcriptome, and I'm going to change this from a T to a C. Now, with any luck, if I'm going to now resume this pipeline, the whole pipeline should start again, just because I've simply changed a single beta, and you can see that that's the case. So the fact that I changed that, changed just one bit of information there, and if I was to resume again, I'm going to be able to know that. Yeah, there's a whole lot of reading you can do on this. There's some blog posts on the Nextflow website, because it's something like 8 or 10 different things are considered when you run a resume on a pipeline, and various options that are available to you for changing the leniency of that resume function. Okay, quickly, I'm just going to add some directives into our pipeline. So we saw these before. I'm going to add on the quantification step. Let me add a tag in here, and this would be a good place to put, for example, the sample ID or the peer ID in this case. This is going to allow me to view each one of those, and I want to do publish dir as well. Let me do publish dir, and I want to run this now. Now let's publish dir, but let's use our Nextflow parameter here, so we can parameterize where the outputs of our pipeline go. Let's use params.outdir, and let's do something called quant. So this is now the outputs here. This should be a $sign. This should be now, we're going to create a parameter here, which is going to be able to be defined from the command line if we want. By default, it will be results. And the output will go into this directory inside this quant folder. So if I run this again, I'm just going to firstly remove the results. And then I'm going to run. Now we should hopefully find the quantification results actually get placed inside here. So if I look onto the left-hand side of the screen here, see results, I've got quantification. And for each of the tasks that we've run now, you can see that we have the sample for guts, sample for liver, the results of that, and the sample for lung, all in a location that's easy for me to access, so I don't have to dig inside. Another question is, how do I know that, that the index channel is a value channel? So in this case here, because it's a path will by default create this is a helper function, which is going to create an index channel because it's just a single file in this case. The alternative way of writing this would be if we were to go into here and we were going to say like transcriptome channel would equal, it would be a value channel based on a single, if it's a single file, it's always going to be a value channel in this case. If I have multiple files, it's not going to be. So there's a specific file helper function, which does it for you in this case. Shouldn't peer ID be below input? Because peer ID, it's another question, peer ID variable has not been created yet. Yeah, so there's actually there's no ordering to this. So the question is, how can I use peer ID here when I haven't defined it here? And the specific ordering, it's not reading this from top to bottom inside the process definition that we have here. Another question, is it possible to add publish dir conditionally on some variable, i.e. to have a task with publish dir being set only if the sorted output equals false, otherwise to run some sort output on its own publish dir? I'm not sure about that, to be honest. Maybe I'll leave that one to Paulo. A conditional publisher, I think I would be surprised if it wasn't possible. I don't know how to do it off the top of my head. I'm sorry. Okay. Slowly getting there. So we've now created this, the inputs to our parameters. We've done the indexing. We've done the quantification, which ran for every one of our samples that we have. Now let's do something, something slightly quick. Now we're just going to pull in to do a quality control. So we're going to use script number 5 here. This is a fast QC step. Everything in this pipeline is identical as before. So we've got this here, fast QC. Now it's a new process that we have. We can see we've got a tag fast QC on sample ID here. Our input is exactly the same as the read peers channel from before. It has the same structure of a value of the sample ID. Previously we called it peer ID, but this is however you prefer. The reads from the read peers channel. Now we're going to, in the script section, we're going to create firstly a directory, which is going to be some logs which contains the sample ID as part of the file name, the directory name. We're going to run fastqc with the output using this directory we've just created, and we're going to define its fastq files and the reads there, which is going to come from this location here. And now we're going to see the first kind of limitation, one of the limitations that we had on the original Nextflow, which is now being fixed. I'm just going to change this to run script number 5. Again, we can see with the resume. And what we can see is that read pairs channel has been used twice. So this is something we've mentioned a few times, but this read pairs channel was used as an input both for fastqc and for the quantification. Now, as of the latest release that's coming up in next week, this will no longer be a limitation, but for now, for your next 7 days, you have to do this. So we have to split this channel into 2 using into. So I'm going to create one channel, which is called read pairs channel and read pairs channel 2. Now in the strict definition of data flow programming, this is what's necessary. This is what's required to do. And we've essentially modified how that library works underneath so that Nextflow is able to kind of look ahead. And what it does in the new version is create that channel for you sort of on the fly so you don't have to do this. So I now split that channel into 2, gave them 2 unique names, and now we can run. The question is, yeah, so there's the 2 channels with the same content. In this case, yeah, they're exactly the same. Another cool thing to note here is you notice that we ran script 5 and before we were running script 4. However, we used resume and it still was able to take the cached, tasks from the previous execution, even though we were using a different script. So Nextflow's caching mechanism is looking at each task independently of where it's called from. And this enables you to have a shared work directory with your colleagues or on a large system you can imagine. And if a task has been seen before, if it's been run before, you no longer have to run it independently of the script that you use. So this is a kind of pretty cool feature, particularly if you're iterating over pipelines or you have common tasks which are run across your lab or across different institutes or sort of with collaborators. You no longer have to redo all that compute again. Okay, so we can see that the 3 tasks were run for the fastqc process. And you can see that we have this tag that was based on there. We're able to split those up. Okay, multi-QC. Let's bring it all together now. Let's now take those 3 processes that we've created, the index, quantification, and the fastqc. And I want to pull them now into a single multi-QC report that is going to bring it all together and allow us to generate a report. Let's have a look at script number 6, which contains this. When I look in here, everything is the same as before. We just have a last process on the end here, multi-QC. The thing to note about how multi-QC works is it takes the output or the logs or the resulting of many different bioinformatics tools, something like 80 or 90 of these bioinformatics tools. It's able to take the output from and generate a report. Now, imagine that I have run 1,000 samples or 10,000 samples across many different tools. I don't want 1,000 or 10,000 PDFs or HTML reports. It's going to be completely useless to me. I want to generate a single PDF or single HTML with the combined contents, the combined output of all of my individual tasks. And this is where operators come in. This is where we're going to see how we can take the FastQC and the quants and we can combine them together. Okay, how do we do that? Well, the multi-QC process itself, the actual script section is simple. We say multi-QC dot, this just means look in this directory. But what that means is that we need to get the output of those previous tasks into this work directory. And the way that we can do that is by using this line here, which is the key part of this pipeline, really bringing it all together. What we're going to say is path anything, so all of the files, we're essentially not giving them a name, we're just going to use their original name. But we are taking this from the quant channel, we're mixing the output of the quant channel with the FastQC channel, and then we're going to collect it. Let's just run this once, and then we'll split this up to see exactly how this works. So again, I'm just going to run script number 6 here. Okay, and we can see this is doing exactly what we want. So we had quantification running 3 times, we had FastQC running 3 times, but multi-QC ran just once. And the reason for this is directly because of how we manipulated this channel. And I want to show you another way of manipulating this channel here to show you a little bit of how this works. So what does this actually contain? What is this new channel we're creating on the fly containing? Well, we can just view it. If we do view here, we can see that if we were to launch this, this is now a channel which contains a single element, and that single element is the logs or the output of those different processes, of all of the tasks of the quant channel and all of the tasks of FastQC. If we were to, for example, take off the collect here, what would we have? We would have a channel with 6 elements. And if we were to run in this manner, we would see that multi-QC would run 6 times. So if I was to take this back, place this in here, if I was to take off collect, for example, I would get 6 multi-QC reports, which would be not so useful for us. So here we can see that it's the way that we can use these operators to change the contents of the channel that is able to drive the execution and is able to control. This is really like the data flow aspect of Nextflow. We are defining what is in the data flow, what is in the channels to define how our execution works. So hopefully that's clear. We can now see that we've placed and created a report here. So this will be inside results. We can see that there's a multi-QC report. I'm not sure if this renders okay. So this is actually just rendering. This is just the HTML, so it hasn't rendered, but you can trust me that that's been created there. And we could see the output of our pipeline. Okay. Last little thing on this bit here, there's also ways that we can look at capturing events. So we could, for example, I'm now looking at script number 7, and there's another line in here for this is an event. So on the completion of the workflow, you could, for example, produce, if it was successful, print some output. Or if it was not, print something went wrong. This is just a little capture feature that you're able to use. What I want to show you, and I think what's more important here is the way that we can use Git, and we can run these pipelines directly from Git, specifically this pipeline we've just created. So I'm going to close these ones here. So far we've only been working locally. We've just been writing these pipelines with the scripts that have been provided or the scripts that we've been writing ourselves, and we've been running them. The real powerful way of running a Nextflow pipeline is using this Git integration. And we have the same pipeline that we have before. So this is this Nextflow RNA-seq. If you look and type the code here, you'll see that it's very much essentially the same as that we've just been creating. And we can run any Nextflow pipeline using the actual, just by calling it from Git directly. So Nextflow pipelines or Nextflow projects are just Git projects. In the same way that I was writing before, Nextflow run and then the script name, for example, script 1, etc. I can also provide a Nextflow project or a Git project here. Oh, let's close that one. So for example, I could say Nextflow IO-RNA-seq-NF. Now you can see that this is actually just the location, sorry, this is just the location of this. And when I launch this here, you can see that it's going to pull it from GitHub. And then when it pulls it from GitHub, it's going to then launch that pipeline. And you'll see that's very similar to the pipeline that we had before. So we can launch things directly from Git. And we can also use all of the Git tools that we have available for us. So we can say, for example, the Nextflow information, we could, for example, pull a pipeline from that. We can check out which version of our pipeline. We can even run a specific version of a pipeline based on a Git release or a Git tag. So I could, for example, pull a revision of this. I could use this Git tag, or I could use a release. So imagine that I had this release here. I could say I want to run revision 1.2 using the R tag. So Nextflow, again, it's the same thing we had before. If I just use an R, here I can say run version 1.2 or run version 1. Whatever. Another question, can you use a local GitLab server? Yeah, so you can use any Git, any Git-based system is out there. So there's support for GitLab, Bitbucket, GitHub, and I think there's actually a couple of others, Gitaya. So this is a couple of open source versions of Git hosted systems which you can use. And this is exactly the approach that we have in terms of using with Nextflow Tower. So we really kind of believe that this is the way of running pipelines in the future, that keeping everything in your project inside a Git project is the way to make things really robust. And that's why when we say with Nextflow Tower, when you go to launch your pipelines in here, that everything here is based on a Git thing. So now we can launch the exact same pipeline I showed you before. I'm going to run this in Europe, say. I can choose the pipeline that we had. Again, I can choose a revision. This is actually using the Git API, so it shows me all of the versions that are available to me that I can run. I could, for example, just choose a default, choose a working directory. And now when I launch this, so it's launching the exact same pipeline we showed you before, and it's just launching it inside Tower, where I no longer need to have the resources set up. So I can see, for example, the parameters and then get some more information on how that's run. Okay, some other small things that we have, some things to note. So there is a way of running where you can create a mail server. This will be able to send an email to you on the completion of the pipeline or the failure of the pipeline. You can also do that in Tower now. It's probably the more recommended, more stable way of doing that, as it contains a server built in. Other thing that's very useful is, imagine that we wanted to externalize our script. So FastQC here, and I go back and look at the FastQC step. And here we have, you can see we've got a couple of lines of bash. But imagine that this was not 2, but it was like 10 lines, or it became 20 lines or 50 lines, and it was different language, or however you like. It gets to the point where maybe it's not the best place to put your script in this location. It can become a little bit ugly. It can become a little bit more difficult to handle. Maybe you want to externalize this part. And we can externalize scripts in Nextflow using the special bin directory which is available to us. So following this example, I'm going to create a file called fastqc.sh. This is a bash script, but this could be a Python script as you prefer. And I'm going to place it inside the bin directory itself. So in the first case, I'm just going to make a directory called bin. I'm going to cd into that bin directory, and then I'm going to create this file, which is called fastqc.sh. Inside here, I'm just going to paste what we had before. Notice that this is a bash script. It's going to have two arguments. The first one is going to be now a variable sample ID. The second argument is going to be the reads file. And the actual script that's going to run, this is just pure bash, where I can have the variables here. So this is now bash variables, because this is a bash script. I'm going to save that. I'm going to make it executable. So chmod on that one. And then I'm going to cd back. So cd back onto that. Now, when I call this inside this Nextflow, I no longer need to have all of the script section, because I've essentially externalized it. And you can see that we just need to call the script itself. So fastqc, sample ID, and the reads. Let's check that. So this is going to call now our script. Notice that we don't have to specify the full path of this fastqc script. And the reason for that is that because we've placed it in this bin directory, Nextflow automatically adds that to the path, and it adds that to the path in a very portable manner. So it adds it to the path independent of the execution environment you use. What do I mean by that? Imagine that I'm going to go now execute this with AWS Batch on a virtual machine, and I'm launching this from my laptop. Nextflow will upload the scripts section, the script to that virtual machine, or to the S3 bucket. They're then going to be able to pull from the virtual machine and run the pipeline in that way. So you have to kind of keep in mind these things, and that's why there's many built-in mechanisms in Nextflow which enable this portability, providing that you do it in the correct way. So that's that here. Notice that this is here a Nextflow variable here. So this is the sample ID, and we can run the same pipeline as before. So now I'm just going to run script number 6. Same as before, actually, and this will just launch there with the externalized script, if we're lucky. Yes. Okay. Other things you can see here. So you can see that we have these options. We can create a report. We can create a trace when we run the pipeline. This is a way of seeing each of the individual tasks and kind of creating some metrics for each of those, capturing those, timeline and a DAG. You can see how to run all of these. As I say, some of these features have been sort of superseded by Nextflow Tower, which kind of builds in many of the dependencies that are required to run these things, and you can even run those sort of from your machine and then visualize them inside of Tower. Other things to note. So we've seen how we can run a project from GitHub here, and there's some examples that you have here. So I hope that was able to bring everything together from the things that we've launched. And there's a question. Just finish with one question. So if I run a pipeline from GitHub which has a script in the bin, do I still have to cmod it? No, those permissions should be fine. So when you run from it's actually a good practice to really have your pipelines working in GitHub exactly like we have in this example, with some setup data that works, and then you can be kind of guaranteed that anyone who uses that as a starting point for developing their pipeline can run. And that's the whole philosophy around some of the NF core pipelines as well, is that they should just run directly from pulling them from any Git location. So we've seen how we can pull all the syntax together. Now we're going to change gear a little bit and move on tomorrow into more of the config side, so more of the DevOps side of our pipeline development. We're going to begin with an hour-long jump into containers and dependencies. And this is actually slightly an aside to Nextflow. It's not really specific about Nextflow. And we're going to jump in there and go build our own containers, see how we can run these containers, look at a few of the alternative systems to Docker. So look at how we can use Singularity, how we can build containers with Conda, and particularly with BioConda and the kind of benefits that provides us with. And then for the second part of tomorrow, we'll go and look at Nextflow config itself. and the options that are available to us in the config, how we can structure our config files, use profiles, etc. So thanks a lot for your time. I will stop the live stream, and we can then I'll also answer some other questions if we have.